produced by the open students and the researchers who would like to explore the soil database, they can go through these things. However, and we are about to finish, and here is the very important problem, that the data density divide. As I was I mentioned in the beginning, that algorithmic colonialism. So let's talk about this. We know that there are some regions of, for example, the Europe, North America, and Australia. I mean, they have a long history of soil survey. They have their strong institutions, many soil profiles, and better observation networks. But many regions are data poor, like the sub-Saharan Africa, the Central Asia, the Southeast Asia, and parts of the South America often have also very limited soil observation. And this creates actually a global inequality in the soil mapping. Because if a digital model is trained mostly with data from Europe or North America, then how can it work well in Africa or Asia, right? This is a question, very important question to me. And also the relationship between the climate, landform, vegetation, and soil may be different. So what happens that this creates the risk of what we can call that digital algorithmic colonialism. That means the models that developed in data-rich regions may impose their assumption on data-poor regions without enough local calibration. So digital soil mapping is powerful, but it also can reproduce global inequalities if local data and local expertise are not included. So along with the data quality, that local participation and local expertise is also very important. And this slide shows some efforts to reduce the global soil data divide, as I mentioned over that AFSIS and Global Soil Partnership. And however, anyone who would like to explore the soil data, they can check through these databases. And I mean, the main message of this slide is that open data alone is not enough. Okay, countries also need the capacity building, the training, laboratories, institution, and national ownership of soil information. And the digital soil mapping is important in the sense that this is cheaper, it is faster and reproducible. That those are the major benefits of digital soil mapping. And in the digital soil mapping, the large scale soil maps can be produced much faster. So these are the benefits of digital soil mapping. Okay, now we move to the future of soil mapping. I mean, in the past, the soil maps were static. Once a map was printed, it just stayed for years. But the future idea is a living soil map. That means that we can say that real time. A living soil map can be continuously updated with new data from satellite sensor, field observation, and citizen participation and science. So the idea is connected to the concept of a digital soil twin. Perhaps we have already heard, some of us heard the digital soil twin scholarship or the program from the Erasmus Mundus about soil. So it's the idea was like this. A digital soil twin means the digital version of the real soil system. It will help us to monitor the soil health, and new technologies are helping this future. And there are some sources though provide the satellite data for soil. For example, the NASA's EMIC missions, they provide the hyperspectral data from space, and other things are here. So not elaborating these things. And we are now going to say that the future soil mapping actually must cross several borders. The first one is example is the European Union's Destination Earth, or the DESTIN-E program. This program aims to create a highly accurate digital replica of the Earth system, and soil digital twins could one day become the part of this larger Earth system and model. And there other development is the EU soil monitoring law. And however, what the key point is here, that the future of soil mapping is not only a technical issue, but it's also a governance issue. And we need some common standards, legal frameworks, data sharing system, and international cooperation, because you know that the soil is not a static resource that only belong to a single country. It's shared, common resource, shared resource. So we need some sort of standardized and universal systems. And without this, even the best technology will not be enough. And this is a little information about Bangladesh, because Bangladesh is located in the world's largest delta, and the country has very large population with a very fertile soil. And soil is most important resource for any of the country, because it is directly related with food security. So we're not going to discuss about the Bangladesh thing or whatever. This is just for your kind of information. Just to mention the thing that if soil health is not maintained, the food production will be declined in the future. So for Bangladesh and other developing countries, soil mapping is not only a scientific issue, is directly connected to the food security, climate resilience, and national development. And this slide focuses on Bangladesh's most serious soil problems, coastal salinity, and we know that the similar problems is prevailing over other countries of the world. So it's important that soil mapping and prediction of soil quality is urgent intervention. Well, and this is the SRDI, that is Bangladesh's National Soil Survey Institution, and how it works and how it developed. And this is important because it shows that this slide shows that Bangladesh is not alone. Many developing countries face similar challenges in soil information system. They often have old funding, insufficient technologies, and weak digital infrastructure. And maybe in this case, we can use some alternate pathway like the FAUS Global Soil Partnership. I mean, this purpose of this slide is how we can access to the soil digital resources, since we do not have that much facilities of ourselves. So another pathway is GLOSIS and WSIS integration. If Bangladesh contributes the legacy and new soil profiles to the system, the country can gain visibility and benefit from the international quality assurance. Although it cannot have its own system, but at least it can develop. I mean, the main message is the Bangladeshis should not only use global soil maps, it should also contribute to its own data expertise and leadership along with other developing countries. And the data sovereignty and global sovereignty is important thing, because there are some important questions. First, who owns the soil data? The second one is, who is accountable? That means if a global soil model gives a wrong prediction and that prediction leads to poor policy decision, so who will be responsible? Since all of the models are based on the North American and European data. And the third one is, who benefits commercially? Soil data can be valuable for agriculture and insurance and environmental planning. And if companies make profit from global soil data, should contributing countries also receive benefits? Well, these are not technical questions, and these are questions of dispute and debate, but I believe they are legal, political, and ethical questions. So there can be a lot of difficult questions about benefit sharing and accountability, but these are still important and unresolved questions, so it should be addressed. And overall, we can say from the entire presentation, let me summarize the main parts of the presentation. That is, the first, soil mapping has passed through three major eras. We have already seen that the first was the analog field from 1900 to 80, and then 1980 to 1990s, and to the 2010s. And still now the third era is emerging, living, that means the real soil maps. And second, the main problem throughout the history was been borders. There were political borders, classification borders, that means classification problems, data borders, governance borders. Third is the digital mapping, the problem. Soil mapping, that means has transformed soil science. Is this faster, cheaper, and more reproducible and more transparent, but it is still incomplete. It cannot replace the field work, and it cannot solve data poverty by itself. And finally, countries in the global south must lead their own soil mapping future, because international support is important, but without local data, local institution, and local expertise, soil mapping system and soil prediction system cannot be developed, and this should be remained at the center. So this is all about my presentation, and I wanted to talk about that. So thank you very much. I hope, well, although it's a bit boring discussion, but it might be
No,
insightful.
okay.
Thank you so much. Thank you so much. And for
Okay.
your references, we are here. Maybe
Oh, okay.
for that. Thank you so much.
Thank thank you very much, Ms. Ifara. Okay, the first time this is first knowledge for me about soil mapping, and then they change for DSM, digital soil mapping.
Yes.
Okay, that is also was a wonderful journey for traditional soil survey to digital soil mapping. I would like to add a few questions. Okay, the first question is from pencil draw map to AI based prediction. What change in soil mapping surprised you the most? It's mean when you change from using a pencil to AI.
Okay. The most surprising change is how accurate the soil mapping has become. because in the past, as I said in the slide, that the method was very much analog. We have to go to the field and it would take a long time. But right now, with the digital integration and machine learning technology, the map can be produced in much faster. The workload has reduced significantly. That's the most significant observation. However, but field knowledge is still important because artificial intelligence needs the real observation to learn from.
Okay, for a beginner like me, for the beginner like me, so I know just a basic about GIS and the soil mapping. Okay, for a beginner, are they need to learn from basic to advanced for learning soil mapping DSM? Are they need to start from pencil draw or just go to the DSM for the beginner?
No, for a beginner, anyone should start with the analog
Analog.
methodology, I believe. Because if anyone doesn't know how to work in the field, then how would he or she understand the data digitally? So a beginner should start from the field and collecting the manual
Manual.
methods, and then how to analyze those data also needs to be learned manually. Well, once the beginner is familiar with the analog techniques, then he or she can move to the digital platform.
Okay, this means they must understand about analog first, and then they will go to the advanced AI for mapping.
Yes. Yes.
Okay, that is so fascinating. The speed of change are very impressed, but the field's knowledge is still remain very important. Okay, Miss Ifat Ara.
Yeah.
Do you think a machine can truly understand soil? Or are they mainly prediction pattern or soil type?
Honestly speaking, a machine will understand, but in machines will, not like us. A machine can never be a replacement of human, and not in the way a soil scientist or farmer can understand. A machine does not feel the soil; it cannot smell it, and it even doesn't understand the local history. So it
Yes.
mainly finds the pattern from the data, right?
Mhm.
So yeah, a machine definitely cannot understand, but yeah, it can still be useful. They can show where the soil may be salty or can represent the pattern, and that's it. But definitely, machine cannot understand the soil, but it can make us understand the pattern.
Okay, they can make us understand the pattern. Okay, there is a very balanced answer. AI can detect pattern, but humans still can give meaning to those pattern. Okay.
Yes.
Okay. For the next question is what is the biggest challenge for developing a country like Bangladesh face in the digital soil mapping?
Mm, biggest challenge is actually handling the soil information, because we know that Bangladesh, as well as many other developing countries, the soil data is old, scattered, and not fully digitized. And for AI-based soil mapping, we need the referenced and updated field data, databases, skilled people, and institutional support. So, and we know that without those, even the best technology cannot give reliable maps. So these are the major challenges.
That means the data is a very major issue. Without update or digitized data, even advanced technology become limited to access and to build a mapping. Okay, that's right. Okay, if you can you could solve one of the global problem using soil data or using the DSM, what would it be?
I think I would choose the food security, because in one of my slides I mentioned the soil is directly related to the food security. I mean the crop production, but many people, they do not realize how important soil health is. And good soil data can help farmers to know the plant types. What plant they would like to cultivate, and where to farm, and how much fertilizer to use, and how to protect the land from degradation. So better soil information can support better farming and better food systems.
Yeah, that's right. Food security is much such an important answer when we talk about soil, we will talk about farmer, plants, what they want to use, how they want to plant it. Okay, so soil health is directly connected to the human survival. Right? Okay, in the future, do you think farmer? This mean this is the last question from me. Do you think farmer will really more on AI than their own experience? Are they using the experience for their old way, or they are using the AI for the advance for the farmer?
Okay. I think the best future is not AI versus the farmers. It should be the AI with the farmers or AI plus farmers. Because farmers have years of practical knowledge about their environment, that means their land, weather, crops, the local condition, right? And artificial intelligence can add extra layer and extra support by just giving predictions, alerts, and the maps. I mean, when both work together, the farming can be smarter, right, and more efficient and more sustainable. So that it's not a conflict between the farmers and the artificial intelligence. Rather, it should be a coordination between these two.
There's a beautiful point. Okay, the future is not the AI versus farmer, but the AI with a farmer. That means AI and farmer will be together to solve the soil problem, or to create something benefit to the country. Okay. Then thank you again, Miss Ifat Ara, for such information and thoughtful presentation. Okay, now
thank you so much.
Okay, thank you. Now we will move to the audience Q&A session. For the participation, please write your question in the chat box. You may mention which speaker your question is for, and you can keep it open for both speaker, or you want to ask directly online, can also. Okay. When a correct question, I would like to say the both presentation remind us one important thing: technology is growing fast, but human knowledge, local experience, and ethic use data are still essential. This is the important one. Okay, we wait for the question in the box chat. Any question from the participant?
Dr. Ihsan?
Yes.
I just received 2 questions from my side.
Okay, you can choose who you want to ask.
Oh, it's actually I think they customized the question to both panels. One is for Dr. Enamo, and one is for Dr. Ifat. So can we start with Dr. Enamo's question first? I think it's related to the question, to the slides that Dr. Enamo just presented just now.
Okay.
The question is like this, is it a sign that this he write like this, okay? This is the first time I heard of GeoAI. Is it a sign that we are more and more rely on AI now? And will there be a day that GeoAI just surpass us and we didn't even realize about it? And he puts exclamation marks there, not question marks, but exclamation marks there. It shows that it really has the passion to ask about this question. The question, this is for Dr. Inamo. I just received the question.
Okay, so you want to know that GeoAI really helpful for us for our daily life, right?
Yeah. Yeah. He said, will there be a day that GeoAI just surpass us and we didn't even know about that? Yeah.
Okay, well, if you go through all the slides, first I show you how GeoAI is helping in our daily life, for our domestic, for gardening, for driving car, etc. Right? After then, I come into that, how we can use this AI in our field, especially for our geography. If you check, GIS, one of the very important and significant field for our geography. Later on, I show how AI can help us in our geo. And then I choose that GIS. This was much more specific and pinpoint. And over of my slides, I show how we can use the AI in our GIS. I think now it's clear to you.
Yeah.
Okay.
I just heard it, and I'm very clear about what Doctor just said just now.
Okay, you want to the next panel to answer it, Eric?
There's actually a question to Dr. Ifat, but I saw there's a question typed out in the chat box. We
For
can.
Inamol, eh?
Yeah.
Can I read it? In the slide we saw, GeoAI is beneficial to human and human activity. But what about the plant and animal? How can GeoAI be helpful for them? Oh. Yes, Inamol.
Here I can say, now I can recall my memory. When I was a student, I think second year or third year, maybe. That time, one of my teachers, he was teaching us about the classification of living and non-living organism. First, he said that one is plant, another one is animal. Here I can see that one, plants and animal, right? That time I was very curious. Human being, we are animal. Because in a broadly, we just classify plant, living organism, plant and animal. Then I asked my teacher that, so whether we are animal, then he said nothing. He just laughing at me. Okay, just for the kidding. Yes, you can say, if I can correlate that one, animal as human being, yes, of course, it is helpful for us. Sometimes we also can track whether the wild animal, where they are going, is they are going to the desert place or not. And sometimes, you know, the wildlife is danger for our human beings as well. If we can track their route, where they go usually by the satellite image and analyzing that, then we can use that and it's much helpful for us. And for the plants, of course, by the satellite image, we can detect whether the plants is growing well in a natural process or not. If we can see there is any abnormality, then we can treat them. Maybe they need some treatment. For example, maybe they need some fertilizer, maybe they need water, maybe they are facing some diseases, then we can treat them. Yeah, GeoAI, of course, helpful for both plant and animal. Yes, I do agree with you. So, Jessica, it's okay?
Okay, I hope Dr. Inamol answered the Jessica question. Okay, next we have for the Miss Ifat Ara. The question is, do we have advance in developing our DSM in Malaysia and Bangladesh since we share the same climate? If yes, what are the advantages? Ms. Ifat Ara, can you open your microphone?
Okay, yes. Can you hear me right now?
Yes, clearly.
Okay, thanks. Well, what I would like to say that yes, definitely Bangladesh and Malaysia, it's possible because we know that we have similar climate and we both are located in humid tropical environment. However, the climates are similar rather than exactly the same. So there are several advantages like shared tropical conditions. I mean, both country we share high rainfall, temperature, process, intense monsoon influence, rapid organic decomposition. Then we have similar environmental covariates. That's why that means algorithm trained in Malaysia can partly help in Bangladesh models, right?
Yes.
Then covariate relationships may be easier to adapt because of the similarity in the variables, and regional DSM collaboration can be more efficient. Then we have another benefit, that is the technology and knowledge transfer, because we know that Malaysia is more advanced in remote sensing and GIS applications, precision agriculture, and environmental modeling. So Bangladesh can be benefited from their joint research, shared methodologies, and so on. And if Bangladesh and Malaysia collaborate, the existing workflows can be reused. I mean, there will be the reproducibility and reusability, right? And training time would be shorter for the data set. Regional data sets can also improve and model performance, and it can help in this way. And existing, as I said, that workflow can be reused. So even with similar climates, and Bangladesh and Malaysia still differ in some aspects also, we have to remember that Bangladesh has deltaic landscape and Malaysia has mountainous landscape mostly. There are differences between parent materials, land use systems, and flood regimes, coastal processes. So yes, digital soil models from Malaysia cannot simply be copied directly to Bangladesh, but can be used with proper calibration and field validation, and these will be still required. That's the point. I hope I could answer the question.
Okay, I hope the question from Eric can be answered by Ms. Ira Ifat. Okay, I think this is the last question for our forum. Okay, this for Ms. Ira Ifat. Are there any successful example of soil mapping project in developing country? This requires high resolution image which can be captured using drone. The challenge is very expensive. Are there any funding agency available to help small country in developing countries like Zambia? Wow. Two
Well,
question in one question.
yeah. I got the point. Well, I have already mentioned one project, that the AFSIS project, that was mostly funded by the Melinda Gates Foundation, and they have invested a lot for soil mapping projects in Africa. So if anyone can develop a very good proposal and the idea, so there is chances to get funds, but the project should be very qualityful, I believe, since this is very expensive for the satellite imaging and other laboratory testing. Soil mapping is indeed very costly project, but yes, there are chances if they can prepare their own project. For example, in Africa or in Zambia, you can develop your own project about a decision support system, and you can submit to the Gates Foundation, and there are some other options also, international soil organizations. So definitely there are chances. You just have to proceed with your idea and have to show it.
Okay, that's fine. That is the right point for the answer the question. I hope Ms. Mambo Piri, the answer can be done by Ms. Ifat Ara. Okay, we have now come to the end of today's session. Okay, on behalf of the UPSI Geography Society, I would like to sincerely thank our respected speaker, Dr. Inamul Haq and Ms. Ifat Ara, for sharing their valuable knowledge and experience. I also thank all the participants for joining us and making this forum meaningful. Okay, we hope today's discussion has inspired you to think more deeply about GeoAI, about geoinformatics, about digital mapping and education. Please stay connected with us for the future event. Thank you everyone. Have a wonderful evening. Okay, now I now return this forum session to the chairperson, Mr. Eric, for the next activity, for example, for photographer session or QR for the e-certificate. Okay, I give back to the Eric. Thank you.
Yeah, noted. Thank you very much to our moderator, Dr. Mama Isan, and esteemed for the deeply insightful and engaging discussion. Ladies and gentlemen, we have now reached the conclusion of Forum GeoBridge 2026. On behalf of the organizing committee, I would like to express our utmost appreciation to our moderator, Dr. Muhammad Ihsan bin Muhammad Ismail, and our exceptional international panelists, Dr. Muhammad Inamul Haq and Madam Ifara, for bridging our perspectives and sharing such profound knowledge tonight. Thank you also to all participants for your wonderful support throughout this event. Okay, before I will officially dismiss, please pay close attention to several important announcements regarding your attendance and certificates with the display QR code. The technical committee is now displaying the attendance link QR code. Please scan and fill out your details immediately for attendance tracking. For OPSI students, the MyChamp QR code is now being displayed. Please scan it according to your university merit points. For international participants, please take note that international participants will not receive MyChamp points, but all of you will be provided with an e-certificate as the token of appreciation. We would like to tell the international students that the e-certificates are currently being processed by the committee and will experience a little bit delay. Because of this, it is compulsory, necessary for all participants and committee members to remain in the official WhatsApp group being set up. The link to download your e-certificate will be shared directly in that WhatsApp group as soon as it is ready. Please ensure you have filled out the attendance link and scan the necessary codes before you leave this session. Again, thank you for your time, stay safe, and have a wonderful evening ahead. May God bless you and your loved one. See you next time.
Okay, thank you. Thank you, Dr. Emo. Thank you, Miss Ifara.
Thank you.
Thank you, everyone.
Thank you.
Thank you, Fatara, Erika,
Thank you.
Champaka, for arranging such a exciting program. We hope we can do it later, much more
Yes.
collaboration and cooperation.
Maybe more we can invite more speaker in more.
Yes, yes, in future.
Yeah.
This is the beginning.
Yes.
Okay, good night.
Okay. Good night. Assalamualaikum.
Assalam. See you again.
Yes,
See you
yeah.
again.
See you again.
It was good to see everyone. Thank you.
Waalaikumsalam.
Eh, tidak ya.